Hi, everyone. For our very last session of Portal Talks 2024, Javid, I ask your forgiveness for putting you to be the very last person today and for the entire 2 days. We have Javid from Upbound, and he will be talking about Upbound and Port Together for infrastructure made easy. And the stage is yours.
Oh, hey everyone. My name is Javid Habibi. I am staff solutions engineer here with Upbound. For a little bit of background, based out of Seattle area, I'm a former AKS CSA from Microsoft, and looking really to kind of dive into this subject. I know it's like very kind of like close to home for a lot of us, and particularly for looking at the power of combining port with particularly with the recent like CRD discovery and Upbound with managed control planes and what we can build and enable for ourselves. So in this process, kind of going to level set here in the beginning. And I'm going to talk about, so just a lot of stuff that we've been hearing over the last handful of years is definitely picking up popularity. We're seeing a lot of movement and emphasis around platform engineering. So we're going to like our responsibilities when building out these platforms, platform engineers, designing, implementing these platform infrastructure, automating these the infrastructure and the deployment of the applications, particularly in a self-service model to be able to increase velocity, providing troubleshooting, debugging support when needed, because it's at some point in time, without any question, there's going to be something that goes wrong we do need to dive into. We want to be sure that in these experiences that we're providing, we are following best practices, security, and compliance guidelines, and implementing the appropriate guardrails for all of our customers when we're building out our clouds. And on most importantly, too, making sure we have the proper monitoring in place, leveraging and sharing the services and tools across the company, increasing the collaboration, increasing velocity, and managing and updating all of this infrastructure and tools appropriately for our day 2 and day 3 operations. So it kind of like with this in mind, like I mean, when we're thinking about this, or building out our platforms, building out for the IDP story, or any sort of platform we're going to have customers, internal or external. Like, what did it mean? Typically, the requirements we're looking at is we wanted them to be composable. We want them to be cloud agnostic. We would like to take advantage and move away from any kind of like hyperscaler lock-in to be able to bounce around as we see fit, or to take advantage of potentially a new service that one is launched, or maybe a new AI model we would like to play around with. Leveraging Kubernetes wherever we can to be able to take advantage of that cloud native Kubernetes native concepts and practices and such. Taking advantage of mature vendor solutions. There's an amazing amount of projects inside of the CNCF that are open source and readily available for all of us to consume. But when it's problem time and we're having Sev once, like tickets cut against us, we do need the necessary support to be able to figure out what is happening at a given point in time with any component we are leveraging inside of our platform. This should be flexible and extensible, because the fact that we're what our requirements are today will not be the same thing guaranteed to be tomorrow. Now, I know this, I imagine, sounds very, very, very familiar to all of you when we're going through this process or we're looking at this. So, like maybe wondering, like, okay, Javid, like, why are you bringing this up? Also, why are the three CSPs here? Like, we're all very familiar with their products and what they do, but I'm kind of going to answer your question with a question in this. So my question to answer your question, potentially run through your mind, is like, well, what do all three of these CSPs have in common that we're working with today to be able to build our own clouds leveraging their technologies? Well, the answer to that is the fact that at the very beginning, when they were building their cloud, one of the first things they built was their control plane. So in order to be able to, so I'm thinking like back in the days when AWS was the operating system of the internet, as they kind of refer to it as that. Or there was an argument going on about, is it Azure or Azure? for that age-old argument that happened. Sorry, excuse me.
So what is it?
So it's Azure. So now with the control plane, like why did they invest in this technology so heavily in the back end? Well, it's because of the fact that it enables this API mandate, this API mindset, so that absolutely every action taken with their platforms is via an API. So for us right now, is that how we're consuming them? We are hitting those APIs, except for the fact that they are very large, very broad, and very unopinionated. Because the fact is, they become opinionated, they start alienating out customers. They want to be able to build this broad source for us to use, except for the fact that we need our cloud. We need the version of our cloud suited to our needs that is opinionated to our requirements. So how can we go about doing this? Leveraging the same exact success strategy that the hyperscalers have been leveraging all along. So this is where I bring up this diagram. We're going to dive a little bit further into like specifically around the components and how each one would fit in and the demo for how all of this works at the end. So first and foremost, we're going to need our UI. We're going to need our front end to be able to interact with this. We want to make sure that our customers, our developers, our colleagues, our platform engineers all have an easy to use interface to be able to interact with our platform and to port in its fantastic environments. Leveraging port, we can be able to create these claims and then leverage a GitOps practice, be able to synchronize them with our repositories, and track all the changes made for every request that is created, deleted, updated via port. Argo can then grab that appropriately and be able to sync them. If we're looking at Argo apps, to be able to make a application deployment, or more importantly, in the early stages, like we're allocating our infrastructure, cross-plane claims, to be able to apply that to your Upbound managed control planes, to then be able to take advantage, to allocate the infrastructure and take care of all those deployments. Now, there's the kind of a caveat there for how I changed my wording. They are still cross-plane control planes, but they are managed cross-plane control planes, and we'll go into the details of what the difference is here momentarily. With this, though, with cross-plane, we're able to take advantage of all those practices of defining with our composite resource definitions and our compositions to build these APIs declaratively. And that is our own opinion. So for instance, in this, we're kind of looking at a clusters of service scenario here, where via port, we are submitting a claim to be able to create the cluster. Argo grabs it, applies it to the control plane, and then goes and creates the cluster. However, you may be noticing there's this other arrow pointing back to port, kind of creating this other feedback loop here that is labeled CRD discovery. This is for the fact that now, very quickly and easily, once we have published our APIs and our compositions and enabling our APIs we want bubbled up to our control planes, port via CRD discovery can grab this, build the actions, build the self-service capabilities, and build the blueprint off of the API that I already defined. I know Victor kind of talked a lot about this earlier on, and we're going to kind of dive a little bit deeper into a kind of a database as a service at scale for like the demo purposes of what that looks like, leveraging this with Upbound. So not only does this enable the fact you can quickly and easily build all your front end with port to be able to enable this self-service capability, it also creates a nice feedback loop. So whenever there are changes, you can quickly, easily sync that with port to be able to make the appropriate updates and update all the fields and be ready to go without having to do a lot of manual work. Secondarily, due to the nature of the compositions that you're building, this scenario here, we're looking at for a cluster as a service. This cluster is not just a vanilla cluster. There's many solutions to provide clusters as a service that hands you an AKS cluster, an EKS cluster, GKE cluster. That's not what we're asking for, though. We're asking is for a cluster that is my cluster. I'm looking for my cluster that has all of the IAM roles set up appropriately, has Datadog configured to be able to ship the analytics, has my log shipment configured appropriately, has all the alerts set up appropriately, has my ingresses configured, has the secret store vault configured, all set up so that when this cluster is handed over to a developer for some experimentation, working on dev, building a new feature, in test, to be able to set up state to go through some integration testing, or to stand up a new production cluster in a new region to enable faster response times for a new customer base that you're in a region you're expanding to. It is at any given point in time, that cluster is exactly what you have defined because it is honoring that contract that you have defined inside of your crossplane compositions and definitions. Now, you may notice that there's another arrow kind of going back to Argo here that is registering that spoke cluster. Because now once Upbound with your managed control planes has deployed this cluster, it can then register it back with your Argo instance as a deployment target for Argo then to deploy all of your applications to it. So you have this nice flowing feedback loop in multiple areas that enables you to quickly upgrade your infrastructure to what you want that is defined and guaranteed to be at n and n+1 because of the active reconciliation that is taking place with your control planes. You have advantages of Argo with your application deployments as well. You have Port being able to grab any updates and changes that you make to your APIs to be able to make sure that whatever endpoint your developers are hitting or that you're consuming is the most up to date, to have this well-rounded scenario that enables you to very quickly and easily build your cloud on top of the hyperscalers. That is cloud agnostic, that is flexible, that is unopinionated, or sorry, that is opinionated on your behalf, and not on the within the CSPs. So I've talked about crossplane here a little bit. And for those that are not the most familiar, I'm going to kind of like dive into that here to touch on it. So crossplane is the open source CNCF project, and Upbound is the company behind it. Crossplane is an extension of the Kubernetes API server that enables you to be able to manage your infrastructure no differently than you manage your pods on a Kubernetes cluster. So by extending the API server, you're now able to declare your VPCs, leveraging our AWS providers. You're able to declare your RDS instances. You're able to declare your AKS clusters, EKS clusters, your data lake instances, or your Cosmos DB, any of the above. But it's not just the hyperscalers, actually. It is any API that can be, you can communicate with our library of providers to be able to do this. So Crossplane, by doing so, enables you to create your own abstractions exposed via these declarative APIs. So now with our infrastructure management, you're not thinking about the scripting and the requirements of what is needed here. Your mindset goes to more of an API design pattern, because the fact that this is by designing these APIs, I am enabling these contracts that I know when I hit it at any given point in time, what I have dictated my infrastructure should look like is what it looks like. Sorry. You take a breath every now and then, get a little too excited talking about this.
I'll say bless you.
So we're able to do this, create our own APIs. We're able to then enable full self-service automation around these APIs, as we're kind of seeing a preview of in the previous diagram. And we're able to build these control plane to power a platform without writing any code. We're not scripting anymore. We're not writing any code. This is all via our declarations. This is all via our YAML. Now, as what we have seen with Crossplane, like, is organizations start adopting this. There are some challenges because there's that caveat that Crossplane is an extension of the Kubernetes API server. What that means is that there is a one-to-one relationship between a Kubernetes cluster, host cluster, and a Crossplane control plane. That is a heavy and hard dependency to be able to swallow. As organizations have been adopting this, though, they have realized that it's kind of difficult to work with a monolithic control plane. That's where you start following in kind of like the anti-pattern of Kubernetes, where you have a named pet rather than a cattle for your clusters and for your control planes, these instances and such. So once they just kind of realize I need more than one control plane, they need more than one instance of cross plane, they start encountering this kind of concept of cross-plane sprawl, due to the fact that you need, for every new control plane, you need a new cluster, and for every new cluster, there's entire lifecycle management around that. It can get quite expansive quite quickly, kind of for a small visualization here in the background. Especially we're looking at like credential management, tenancy, trying isolation, and such. It get quite challenging, and you spend more time managing cross-plane rather than leveraging it. So this is where Upbound comes into the picture, which is the caveat I was adding earlier. I was saying like, and you may have noticed that crossplane's popsicle is a little different on that diagram because these were managed instances of your crossplane control planes. This is, you can think of this as upstream Kubernetes is to crossplane, as AKS, EKS, GKE is to Upbound. You can leverage, you're not spending time managing the infrastructure to run Kubernetes, not spending time managing infrastructure to run Crossplane. You're instead leveraging it to build on top of Crossplane. You're able to leverage it and then adopt it, enable all the lifecycle management without having to worry about the underlying infrastructure that comes along with that, due to the fact that you're working with these managed instances. Now, the terminology that I'm using is, I can potentially perk some ears and be like, okay, this sounds like it's SaaS only. It is not. Upbound has a universal experience, regardless of where it is running. And now what I mean by that is the fact there is the SaaS offering where if you want to leverage this control planes as a service, I don't care about what, like for the fact that Upbound is managing the backend for it. I just need my control planes and I need them to do what I need to do. On the flip side, though, there's many valid requirements for customers to be able to have full control of an environment where it's running, where it has to be inside of their own infrastructure, their own AWS account, their own Azure subscription, their own GKE project. And you can have that with Upbound with our self-hosted version as well. Now, this is all fantastic talk, but I mean, it is just talk until we see it in action. So let's go ahead and dive into a quick demo here and see exactly like what this entails. So for this demo, I was talking about the fact that I'm looking at a database as a service, and I want to be able to enable my customers be able to come and create RDS instances in any cloud that they want to with the small subset of an API. Now, earlier I was talking about CRD discovery and port and fantastic UI, except for the fact I have some YAML here right now. So again, like, Javid, what the heck is going on? Well, this is the definition for the API that I have created. And I'm highlighting this because the fact when I'm looking at my parameter block here, there's only a handful of things that I need. I'm looking for a region, a deletion policy, a provider config name, which is the configuration to tell the AWS provider, Azure providers, or GKE providers, GCP providers, sorry, to which credentials to be able to utilize. What engine am I going to be leveraging here? So for the context of this, I'm set as MariaDB, Postgres, or MySQL. What version, how big, and then some passing in some passwords because I need to for like default passwords and such, just for the purposes demo to make it easier. I'm referencing some secrets that exist. Now, again, I'm showing you YAML here. This is not great. I know you don't want to deal with this. Your developers don't want to write YAML. This is not an ideal experience whatsoever. This is where CRD discovery with port is absolutely amazing to come in and step in. So for the very beginning, you have to creating a new data source, which I've already go ahead and done. I have connected a Kubernetes data source with CRD discovery to my control plane. So for the purposes, so this named CTP portal database as a service. And I am leveraging the CRD discover and filtering on some very specific fields. And what I'm filtering on is the fact that it is of kind composite resource definition, which is what I was just showing you previously. And I'm looking for a specific instance, which was my X SQL instance database service upbound.io. So this is my cross-plane SQL instance composite resource definition on my control plane. Now, you may be kind of thinking about, wait a second, this is a Kubernetes resource, except for the fact you said it's a managed control plane. It is. The managed control planes have their own fully functioning Kubernetes API servers, so we can leverage this. When you're interacting with it, it is no different really than interacting with another Kubernetes cluster, scope within the context of your control planes. So all the commands via the UpCLI, you can interact with it like it is a Kubernetes cluster. To be able to query for the CRDs to see what your current claims are, with this health of the pods, what's going on, investigate appropriately, and all that stuff as well. Now, on clicking sync, what's going to happen here? So I kind of pre-baked some of this because there's a little bit of legwork in the background, as you may have seen, like I was a Victor's talk and like his demo as well. Port goes and creates in the catalog, or sorry, in the self-service, it creates an update and a delete for this instance automatically. So for these self-service, these executions that are now available to me. Now, on top of that, it also created my data model. So I can go look at my SQL instance here. Lo and behold, here are the fields that I need in order to be able to leverage this API that I have defined inside of my control plane. Now, there's a little bit of, because some of the automagic with the CRD fields it's discovering, there are some extra ones with crossplane that we don't care about, that kind of have to be filtered out, which I've done ahead of time. So when I'm looking at the self-service here, we can go and say for like the create instance, and I look at the user form. We can see there's some of the parameters here that, for instance, like the composite delete policy, that is a crossplane instance. It's not something that we care about. So we can go into the JSON to be able to shrink this down appropriately to create a nice self-service capability for developers, just limiting some of the fields and setting visibility to false because they don't care about that. All that they care about is those fields we were looking at earlier inside of the YAML to be able to reference, which was the provider we're looking for, the name, the region, the engine version, how big of a database am I going to be creating, the secret. So so a couple of fields for the secret to be able to reference and pull the password for the default password for these instances I'm creating, and then the deletion policy. Now, a quick thing to highlight here that I always call out is the fact that crossplane and our managed control planes by default are not destructive unless you instruct it to be. So for the purpose of my demos to enable clean and easy cleanups, I set the deletion policy to delete. That way, when I delete the claims, it goes up and cleans everything up inside of my AWS account, Azure subscription, and my GCP project. So this is great. I have my create, same thing with my update. And you can see I've got one that's already pre-baked here to be able to do this. And for my delete, minimal minutes for me to be able to spin this up. And now I can go back to my catalog and start leveraging it via my SQL instance. So let's go ahead and create one right now and get this going. So I'm going to go ahead and kind of cheat here and leverage the JSON, and I'm going to flip back over so it pre-populates a field. So these are just the parameters that you can type in manually that populates a JSON blob, but we're going to review this really quickly right now. So I'm going to go ahead and create inside of Azure a MariaDB instance in the West US region. I'm looking at it being version 10.3 of a MariaDB. I only want 20 gigabytes. Small, doesn't really matter for the context of this. I'm looking at the fact that I need to pull the secret name is the MariaDB Azure secret, MariaDB secret Azure. The parameter password for the key is password, and it lives in the default namespace. So this is just a secret injected into my control plane that I'm leveraging to be able to populate information appropriately. And I'm going to go ahead and say execute. Now, great. I created a claim. What happened here? So what's going on? I created this instance. My GitHub Actions is going ahead and kicked off, has grabbed that payload from port that was generated based off my blueprint on the models that was auto-generated from the CRD discovery, tweaked a little bit appropriately, and creating a claim inside of my repo that now I can see was in fact pushed to my claims directory here, database as a service, that's what I'm enabling. And I can see my default sequences, Azure Demo, Database System MariaDB was created. Lo and behold, here's all the information needed in order to be able to hit this API. Argo now in the background has grabbed this. If I go look at my claims and refresh this, has identified a new claim was created and has gone and immediately applied this to my control plane. So now, if I navigate to the Upbound console while this is going on, I'm going to just kind of go to the homepage of my control planes. I need to go look at my control planes. Now, I'm going to pause here while this is kind of going on in the background. So it's going to take a little bit of time to create this resource and such. This is where, like, first preview you guys see of Upbound here, of this managed control plane experience. What we're looking at is the Upbound console giving you a single glass pane view into all of your control planes in all of your environments. So right now, I'm looking at an example actually of a self-hosted instance that I have deployed inside of my AWS account that is running US West 2 that I have named my Javid Labs AWS host. Now, that's not the only environment I could be running my control planes in right now. I also have the option of leveraging our GCP environment or AWS and US East 1, or a local one running for some development purposes of like what I was doing earlier inside of a Kind cluster. For the context of this, though, I'm looking at my port demo group because this is like scoped specifically to my port users in order to be able to look and be able to access these control planes. So I'm interacting with my databases service. Let's go ahead and look at that. Can I dive in and see what's going on here? And now we can see for my control plane here, for my databases service that's enabling this behavior, I can see I have some configurations that are pre-installed on here because I am leveraging our configuration database as a service that's available in the Upbound marketplace in order to be able to do this, which has installed the GCP network configuration, Azure network configuration. I can see that it pulled in all of my providers in order to be able to set this up that I need for Amazon, for Azure, and for Google, specifically like my RDS to be able to create that in AWS, the provider family for Azure, pulling in like DB for Postgres SQL for Azure, and so on and so forth. I'm not going to list all these because there's a handful here. But what we care about is the fact that, well, I just created this claim for my database as a service. And you can see, yep, there's my Azure demo database as a service MariaDB claim that was created. It's synced, but not ready. What's going on here? Let's go have and take a look. Well, here's a representation of exactly from that one claim that was created, that small form that we filled, that we executed to create action inside of the self-service action inside of port that hit my GitHub action, created the YAML that arrived in that was committed to my repo. So I have my change tracking, my audit capability for all of this. Now, cross-plane, Argo has applied that to my managed control plane, and it is creating all the necessary resources in order to be able to provide this database as a service. Now, for my database, it's not just a database that I need. I need the networking. I need to configure that appropriately. In Azure, I need a resource group. So from that small series of parameters that port knew via the CRD discovery, now my infrastructure is spinning up that is opinionated to my version of this MariaDB instance on Azure, and only a couple of clicks and filling out a form. So this is going to take a little bit. You can see some of these are flipping to green right now in order to go through the deployment. This is all great for creation. Now let's look at, what about day 2? Like where some of you may have noticed that there is most importantly too, I got ahead of myself. The feedback loop continues back. Here is my claim inside a port for me to be able to manage appropriately as well and update. So in that, for my update, I have this other instance here that I said my test database, which is a fantastic naming for the purpose of this demo. I want to update this. Now, when I'm looking at it, I can see that it's running. So unfortunately, it didn't grab the enum there. This is an AWS MariaDB instance, and it's currently running 10.6. So if I go and look at the MariaDB RDS instances for Amazon, I can see there's a much newer version available of 10.11. Let's go ahead and upgrade that. So let's go ahead and update this field, execute it. We can see on the right-hand side, the update SQL instance kicked off. Go back to GitHub, go look at my actions. Lo and behold, picked it up. We're now going through, grabbing that payload, updating the YAML. And if I go, oops, navigate to my code here and at the claims and go look at the database as a service for the my test database. Yep, it's been updated. My claim is now saying it should be 10.11, not 10.6. I can see Argo CD has grabbed that change and has now applied it and synced it. So it's currently out of sync. It's waiting for Upbound to be able to make the appropriate changes. And if I go look now here, momentarily for the next iteration as this goes through. So actually we can get a quick snapshot here looking at this my test database and we can see the current version. Oh, yep, there we go. That's a great little thing too that happened right there. So I went quiet because of the fact you may have noticed there was an error. That error was because of the fact that Crossplane was trying to reconcile against the contract and saying, wait a second, that's not a valid version. Now we can see the engine version is 10.11. So my control plane now is going through the process of upgrading my RDS instance to MariaDB 10.11. So it's still showing as ready because the liveness probes and everything is there. But in the background right now, my database is upgraded. And once it comes back, because it's going to take, takes a little bit of time there for Amazon to be able to do that, I will have a 10.11 MariaDB SQL instance, a SQL or RDS instance in AWS. Now, this is all like great. So I've got my day one, day two. This is the kind of like happy paths. But what happens, so Javid, like I'm gonna like, what about unhappy? We were talking about debugging earlier. Like there's no like at some point in time, there's gonna be something that goes wrong that I'm gonna need to be able to troubleshoot. So let's go ahead and create one in GCP. So I hit Amazon, I hit Azure. Let's go hit GCP. We're gonna go create our instance. Same process, creating. My GitHub action is gonna pick it up. It's gonna apply, commit my claim. Argo C is gonna grab it, apply it to my control plane, and then I will have my new claim that Argo grabs and applies for Crossplane to be able to take the appropriate actions. So it takes a little bit of a moment. There we go. Yep, there we go. So you can see GCP demo was created. Let's go ahead and validate that inside of my claims. Yep, here we go. All right, so I'm kind of fast tracking this a little bit. Well, my customers have been reporting to me like it's just not working. Something's going wrong. I tried to create GCP and there's nothing happening. So I can look at my resource graph here and say like, well, within this, one of the first things that should be created very quickly is my network to be able to support this. Something like if this is not being created quickly and easily, there's definitely something going on wrong here. Looking at this resource immediately via the console, I bubbled up this information. I cannot, the provider currently right now, my GCP provider on this control plane, is failing to configure, attempted to load the credentials, and neither credentials nor access token was set in the provider block. No credentials were loaded. I'm missing my credentials. I can't create in GCP because it's not configured appropriately. So that's kind of a given for like, a very easy thing to be able to figure out in the beginning. But this is just highlights for how quickly you can, when something is going wrong in your control plane for all these actions being taken place via the console with Upbound with your managed control planes, you can drill down to a specific instance and not be running a series of kubectl commands with crossplane. So this is where we start like this kind of, I'm going to grab what we've seen here and grab my slides. I go back to my diagram here. We've been able to see this circle for this feedback loop for the updates that we're making and all the pieces falling in place where to build our opinionated cloud that is cloud agnostic, that is flexible, that is extensible, that we can leverage quickly and easily and provide an amazing interface via port to our customers to be able to establish our cloud leveraging the same exact strategies that the hyperscalers use for us to consume to be able to build out the best version of our platform today. So with that, I'm going to want to pause and open it up for some questions, because I know there are some kind of like some pretty bold statements. I would love to dive into this with all of you to answer that here, especially for how many moving components there were. And I'm going to leave this diagram up as we chat.
I have a question. So first of all, anyone in the audience, feel free to add questions. And I also see Donald from Port on as a panelist, so feel free to add a question as well. I have a question with regards to that was actually raised earlier today. So yesterday, Victor had this demo that was not as detailed as this one, where there was a certain input, I believe with regards to the size of the database or the version of the database, that was an input there. And then somebody asked me today, actually Abby from Cradix asked, do you think all developers can fill that in? Probably, most probably not, right? Because that some developers would need that abstracted away as well. Can you talk a little bit about kind of the form design and what considerations can you make?
Yeah, absolutely. So actually, what? Let me go back to port here.
And let's show the form for a second and then discuss the options. I think it's an important, so not everyone is as current in all these backend technologies as you and Victor. So there's a question here on what forms, what fields would you leave and what would you maybe abstract for certain developers?
So this is really the power that with port and crossplane and the managed control planes of Upbound that you have, is that you have full power to abstract everything away. I could have made this where it's just like all I need is a name and here's the version of MariaDB that I'm going to give you. I could make those decisions as the platform engineer on behalf of my developers, or I can make it as flexible as I want. Now, size specifically to that question, we can utilize enums very similar here to the fact that for my cloud providers, I'm only bubbling up the option for AWS, Azure, and GCP. There are other options out there, and there are other endpoints we could hit with Crosslane appropriately to create these instances. But for my scenario, for my database as service that I'm enabling, is via this. So I could, instead of make this for my storage size, where I was saying like 20 gigabytes, I could say small, medium, large. And then inside of Crossplane, for the compositions and the definitions, I can define what small is. I can define what medium is. I can define what large is. And this comes actually even more in play when I'm thinking about like clusters of service. Like maybe I only need a small cluster for like a developer to be able to do some things, to do some testing. But then inside of like QA, I need a medium, and prod, of course, I need full production like large. Or maybe it could be a dev configuration, a QA configuration, and a prod configuration for the cluster. Any of these parameters for the API you are designing is completely configurable by you, that you can abstract or bubble up. And it kind of circles back to earlier statement I was saying, for the fact that your mindset shifts away from the scripting infrastructure perspective to more of an API design pattern of what information do they need for me to show to them. And then particularly when we're looking at the rapid development, how they could change from day to day, because my requirements today and my developers' requirements today could be completely different tomorrow. I need to push that update, and my developers need to have access to that quickly and easily without a series of rollouts required that the CRD discovery with port plays so well and is so powerful to enable that and bubble it up.
And we could also theoretically completely abstract the small, medium, large and present them as three self-service actions that set up for test, set up for,
Yes,
yeah. So
absolutely.
assuming the small, medium, large leaves the developer flustered or just not having any idea how to answer, you can either provide them some tooltip or even
Yep.
abstract it for them.
Yep. So the great thing here, so this is the auto-generated one that the CRD discovery is able to create that I filtered some of the fields out that were non-necessary. But you could go and create another action here that leverages the same API endpoints, but then provides those values by default inside a port. So you could leave your API inside of Crossplane unopinionated, but then inside a port, apply those opinions to be able to give those various scenarios and bubble that appropriately to the various teams that you want to have access to.
Okay. And you said you made some bold statements. What kind of pushback were you expecting?
So when I'm talking about going with the winning strategy with the control plane, when we're talking about the hyperscalers, that is one of the things. It's just like from the very beginning, we're looking at like for all of us need to build as we're looking to moving to the cloud, as we're becoming cloud native with our infrastructure management, with our applications and such. There is always a challenge within that, from requirements, from data management, from the fact that there's so many more moving pieces. And how is it that the hyperscalers are able to provide the services they are to provide at the scale they're able to provide it without their control planes? So for us, when we're building our services, there's some that definitely are operating at a hyperscale out there. But by and large, for our services and our customers, we're not operating at that level, but we need the same self-service experience. We need to be able to provide that, but within the context of our cloud, without any cloud lock-in, without any for it to be cloud agnostic, and for it to be extensible and easily updatable.
Question from Donald, who, thank you, Donald, for supporting this demo and the preparation for this session. Was there any need, or Donald, do you want to ask the question yourself?
Yeah, sure. Just curious as you were building this, and I know it helped with parts.
Mhm.
But how, challenging or easy did you find it easy to set up and configure the parts of port that you needed for your demo? Was there any specific code you needed to write or anything like this to hook up all these automations and get the ultimate output that you got? Yeah.
So once the GitHub action was set up appropriately to convert the JSON to the YAML with some little offset issues that I had, the experience was actually quite nice. The one bit that did trip me up though, particularly like when we troubleshoot a couple of the issues, was that when we're looking at the SQL instance, so for this like to create, the actions weren't associated with the blueprints. So this button actually, unfortunately, didn't do anything. And then for the changes that we had made, when I associated it with the blueprint, it destroyed them. So I had to go back and recreate my forms, which was a little jarring. That in that action where I clicked to associate the blueprint inside of the self-service here, this drop down selecting it. If it was going to be destructive, it would have been really good to know that that was going to be destructive by selecting the blueprint for what was already existing inside of the user form and the modifications that had been made inside of the JSON. That was the
Interesting.
one thing that did trip me up.
Gotcha.
Otherwise, the experience was fantastic. For the CRD discovery, getting once it was set up and operating appropriately to pull the information in and then to be able to correlate from my CRDs in my control plane for what port was grabbing, and then just limit it, because I don't need the full amount of all the fields that Crossplane is working with, modifying and updating for the context of what I need in my form with port. It was great because it removed so much overhead of manually creating that. And for the fact that it was able to do that automatically, when I go and update my APIs, I can automatically pull those changes in as well, just by clicking that resync. And then I'm off to the races.
Amazing. So yeah, you really achieved all this with minimal help from me. I came in for a few things at the end, but so it seems like you had a good experience with our docs and everything, and to get it online, that's really amazing. Yeah. Yeah.
So thank you. We conclude Portal Talks 2024. See you in Portal Talks 2025, and I hope I see you before that, maybe at KubeCon. It was a pleasure having your demo, Javid, and we'll send all the all registrants and everyone else the recordings.
Thank you very much, everybody. It was great
Thank
chatting
you,
with you.
everyone. Bye-bye.